So the formation of jet stream, the ultimate cause of jet stream is the energy balance that exists between high and low latitude. So how does that happen? The first, there are two types of jet stream we usually talk about. The number one is polar front jet and number two is subtropical jet. So first, the polar front jet. Horizontal variation in temperature and pressure offers the main reason to the existence of the polar jet stream. If you are looking at the left upper corner of the 3D model that shows a side view of the atmosphere in the region of the polar front. Because the polar front is a boundary separating cold polar air to the north from the warm subtropical air to the south. The greatest contrast in the air temperature occur along the frontal zone. We can see this contrast as the minus 20 degrees centigrade isotherm dip sharply crossing the front. This rapid change in temperature produces a rapid change in pressure. So as you are watching that the sharp bending of the contrast, the constant pressure isobaric 500 millibar surface as it is passing through the front. So we can say the sudden change in pressure along the front set up a steep pressure or contour, the pressure gradient. That pressure gradient intensified the wind speed, and that intensification of the wind speed cause to produce the jet stream. If you are observing the lower left, the picture 5b 500 millibar chart, that wind is blowing along the front from the west, and this wind is parallel to the contour lines, and this wind with cold air of its left side. The north-south temperature contrast along the polar front is the strongest in the winter and weakest in the summer. So if you're looking at the right top corner of the picture, that two stable polar vortex and wavy polar vortex, the one is zonal wind, another one is meridional jet stream. This situation explains why the polar front jet shows the seasonal variation. In the winter, the wind are stronger and the jet moves farther south as the leading edge of the cold air can extend into the subtropical region as far as the South Florida or Mexico. It because of the weak polar vortex sometimes make it more meridional and the cold Arctic air move all the way to the south. In the summer, the jet is weak and is usually found over the more northerly latitude. So this is how we get sometime the Arctic air mass, very cold weather into the south of our region. So the second types, that subtropical jet, stream, which is usually strongest slightly above 200 millibar the atmospheric level, about 12 kilometers from the surface all the way to up. This subtropical jet tend to form along the poleward side of the Hadley cell, as you are looking at this picture. So here the warm air carried poleward by the Hadley cell produce a sharp temperature contrast along the boundary. Sometimes it's called subtropical front. In the vicinity of the subtropical front, the sharp contrast in temperature produced a sharp contrast in pressure, and this contrast of pressure, contrast of temperature gradient produce a strong wind. That strong wind flow from west to east direction, and that is subtropical jet. When we examine the jet stream carefully, we see that another mechanism other than the steep temperature gradient cause a strong westerly flow aloft. The cause is the angular momentum of the air. This cause appeared to be same as the which we can see the example when skaters spin faster when the arms are pulled into closer to the body. They spin a lot. That called conservation of angular momentum. So this is one of the reason that jet stream spin a lot.